life, we can think of ourselves as an evolutionary algorithm. And some people, like Yuval Noah Harari, have labeled us living people, organisms, as biochemical algorithms. Biochemical algorithms are a lot of how we actually function day to day. But we can, again, formalize an evolutionary algorithm, and essentially there's two steps, which is step one is generate the initial population of individuals randomly. So that's the first generation. Step two is to repeat the following regenerational steps until termination. So these four steps are: one, evaluate the fitness of each individual in the population. We think about time limit, sufficient fitness achieved, etc. Step two there is select the fittest individuals for reproduction, which are parents. Three is breed new individuals through crossover and mutation operations to give birth to offspring. And four is replace the least fit individuals of the population with new individuals. And this is an evolutionary algorithm which can actually be used to solve problems. And it's a little weird, but you can see evolution taking place in a computer. But here we're speaking of fitness in the context of evolution. And this is a quote here from Fitness in Terms of Biology. The term Darwinian fitness can be used to make clear the distinction with physical fitness. Fitness does not include a measure of survival or lifespan. Herbert Spencer's well-known phrase, survival of the fittest, should be interpreted as survival of the form, phenotypic or genotypic, that will leave the most copies of itself in successive generations. So again, fitness is really about survival. It's about finding your niche, about finding your energy source that has lower competition or that you're better at. But now we get on to something that's really interesting. And it's a paper called The Fitness Beats Truth in the Evolution of Perception. The authors present and prove the fitness beats truth theorem through evolutionary game theory and Bayesian decision theory. Evolutionary creatures who favor seeing the world truthfully and objectively will fail in comparison to creatures who see the world to maximize fitness. A quote from the paper here: our main message in this paper has been that contrary to this prevalent view that we perceive objective reality accurately, attempting to estimate the true state of the world corresponding to a given sensory state confers no evolutionary benefit whatsoever. Rather, a strategy that simply seeks to maximize expected fitness payoff with no attempt to estimate the true world state does consistently better in the precise sense articulated in the statement of the fitness beats truth theorem. So, I mean, you can look at that paper to see exactly what they're saying, but it does have pretty wide-reaching effects. I mean, that's interesting that seeing the true state of reality has no objective evolutionary benefit. Another quote here: evolution can fashion perceptual systems that are, in this sense, ignorant of the objective world because natural selection depends only on fitness and not on seeing the truth. As human observers, we are prone to imputing the structure to the objective reality that is properly part of our own perceptual experience. For example, our perceived world is three-dimensional and populated with objects of various shapes, colors, and motions, and so we tend to conclude that the objective world is as well. But if, as the fitness beats truth theorem shows, evolutionary pressures do not push perception in the direction of being increasingly reflective of objective reality, then such imputations have no logical basis whatsoever. So this does not bode well for us if we want to actually get in touch with objective reality, but it shows the odds we're up against. And this was quite devastating for me, but I was trying to think about it and to think of an example of how fitness would beat out truth. And so if you imagine two birds which both have the same diet of blueberries, one of the birds sees the full color spectrum as it is. In the rainforest, everywhere you look pops with vibrant colors beyond the capacity to name, so it's like Technicolor. The other bird does not see color, but only black and white, while it does see one color, blue. The landscape this bird sees is a continuum of black, gray, and white. However, any blue object shines throughout the background of gray. The blue-seeing bird can spot anything blue with just a look. Now, which bird will be better at finding blueberries? Which bird will find them faster? And I think it's pretty clear that the bird who only sees blue will notice blueberries immediately, while the full color spectrum bird must sift and separate the light pollution of all the other colors. This is part of why bees see ultraviolet light and humans don't. If we saw the ultraviolet light, it would likely have little use in our daily lives. So someone else that I want to talk about is Donald Hoffman, and I'll mention him later, but I wrote this work before I read his book, The Case Against Reality, and he is largely working off this fitness beats truth theorem as well, and heavily leans into it in a way that even I think is extreme. But he sees consciousness as even more fundamental and thinks that we are so incredibly mistaken about the objective world. Like, we think that the world is three-dimensional, at least, right? That there's shapes and sizes and all these types of things. But a lot of these theorems say your epistemology, your ontology of what you think the world is like is just so wildly off. Like, you're so off you can't comprehend. And it could be so vastly different from what we expect. And another way to think about this is journalism versus genetics research. So in journalism, we're having a divergence from reality in a sense because they're trying to maximize payoff. They're trying to maximize the number of clicks they get, the number of ads that they show. And so they're exploiting parts of human nature, like things that outrage us or things that make us feel good or gossip or all this stuff. In the sense that it doesn't even matter if it's true anymore, it just matters if it gets a quick click. Whereas genetics research seems to advance according to the actual state or closer to the state of reality, because the more accurate you can be with genetics, the better payoff you get. And that seems to be a big trade-off here, that you have to match your payoff closely to the actual state of reality if you want to get close to it. Because you can seemingly totally separate your objective reality, the truth, from maximizing payoffs. And you can get some really wild ideas. This is again, though, why I think AI can be so incredibly important and why we can have an artificially intelligent creature who's much better at seeing reality as it is in a way that we seem hopeless, but maybe they have a chance. They don't have to be designed according to maximizing fitness payoffs. And they might be the first creatures who are able to bypass fitness payoffs and go for maximizing viewing objective reality. And I think it's even more reason why we should be investing resources to get them closer to objective reality. I mean, the best tools that we have seem to be like science and math, and that's still really hard for us to do.
Thanks for watching. If you enjoyed this clip, please consider checking out the full video and the series linked in the description.